All right, so we're still reviewing for that MAP test. It is approaching us pretty quickly, May 17th. We're pretty close. So we're just wrapping it up. We're almost to the finish line, so just keep forging ahead, and I promise you this is all going to pay off. I promise. So we're going to review two things today, two things that you don't, again, need to know too much detail about, but I need it to be fresh in your mind, so when they do hit you up with a question or two about it, you're going to be like, I totally know what they're asking me. So today we're going to start off talking about soil. It doesn't get much more exciting than that. So soil, I think we know what soil is, but we can actually put a real definition to it. So what soil is going to be is a mixture of a couple different things. You're going to have what it says small rock fragments or pieces, so small tiny pieces of rock, organic matter, which we're going to talk about what that means. I'm sure some of us remember. Water, we know that, and air, we know that. But the cool thing about soil is it can support vegetation, which is just a really fancy way of saying that plants can grow in soil. Plants just can't grow anywhere. I can't just put a plant on my desk without some soil and hope it grows. You need that soil for plants to grow. So soil is actually pretty important. Now, one main thing I want us to remember is soil is pretty much formed by weathering or the breaking down of rock. So that's where we're going to get those small rock fragments. And the other day we talked about chemical weathering and mechanical weathering. So we're not going to review that again, but just keep in mind those are the two different ways we can really break down those pieces of rock. So let's actually focus over here on the layers of soil. So pretend we are standing on top of the earth, as we usually are, and you're outside, and if you take a shovel and dig deep, 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 deep down, this is pretty much the standard layers you're going to hit. So closer to the top is up here where we are, and then the further down you dig, you're going to reach all the way down here. So let's refresh our memories because it's been a hot minute since we really dove into soil. That top layer up here, this right here where all of this organic matter is, this is what we call that humus. Not the hummus that you eat, different type of hummus. So again, this is made up of organic matter, which is just, again, a fancy way of saying that this is the remains of something that was once living. So you can think of plants were once living. Most of them are still living, but any dead plants would be an example of organic matter, or dead leaves, or if you think about animals, they can have just literally a dead animal, gross, roadkill, or even worse, animal poop. That's organic matter. So that is all going to be in that top layer right up here at the top. That's that humus. Over here, I really will be shocked if they throw this your way, but I'm going to let you know about this term just in case. We know this is the top layer. You might also see it called the O layer, which is easy to remember because O starts, or organic matter starts with an O. So the O layer is at the top where all that organic matter is. So then we hit up that second to top layer, which is really, I think, what we think of when we think of the word soil. It's that topsoil. So it's thin, it's easy to dig into, it's rich, meaning it has a lot of good nutrients for a plant. So if you're a plant, this is probably your favorite layer. It has all the good nutrients it's going to need. And you might see this referred to as the A layer. So right below the A layer, or the topsoil, is the B layer. Makes sense? B comes after the letter A, and we call this layer the subsoil. So this is where it gets, imagine you're digging a hole, it gets a little bit more difficult to actually keep digging because it's made of kind of, you can think of thicker material. It's got that sand, silt, or that clay, which if you ever try to dig into clay, it's not very easy. So the plant can still grow into the subsoil, but this is really where you're going to see the bottom of the roots of the plant. So this is what's really holding that plant into the ground, is that subsoil, or the B layer. Now, if you want to go below the B layer, you hit up the C layer. Again, makes sense. This is what we call those rock fragments. So here is where we have big, someday I'm going to learn how to spell, I promise. Here's where we have those bigger sections of rock. So fragments, again, just means pieces of. So we've got some pieces of rock here. We still have a lot of clay or sand, but not as much because it's pretty rocky. Until you go down to the very bottom, which is that bedrock layer. So bedrock layer is just completely rock. There's no sand, silt, clay, no type of sediment. It's just hard, solid rock. So they call this the R layer. I assume R for rock because it's all rock. So that's pretty easy to think of. Or if you think of the word bed in it, you can think of the rest of the top layer of the soil here is like literally laying on the bedrock like it's a little bed. How sweet. So yeah, those are the layers of the soil, starting with the O layer and then A, B, C. Easy until you hit the rocks where it is the R layer. Already done with soil, we're going to talk about the water cycle now. I know, we're kind of all over the place, but again, this is stuff that you don't need to know a ton about. We just need to make sure that it is fresh in our memory. So we are not even going to hit up, again, the precipitation, condensation, evaporation. We're just going to let that sit, tucked away back in our memory, back in the back of our brains. I've got 4 terms that I want to make sure we have down because if they ask you about water, I guarantee one of these words is going to pop up. Guarantee it. I would bet money on it. So precipitation, we do know is rain, snow, hail, sleet, any type or form of water that's coming down to the earth from the clouds. That is precipitation. So one thing that can happen is if we have a large amount of precipitation, like it rains just so much, what's going to happen is the soil can't totally absorb all of it at once. Because usually when it rains on top of the ground, the water will just seep down into the soil and feed those little plants. But sometimes there's too much rain and it's like, I can't absorb all of that. So that is when we get this runoff. So even think about like if you're driving down the street after it rains a lot and you see like a mini stream that is formed going toward like a storm drain. So any excess water going across the earth, that is that runoff. And you can remember it's called runoff because it's literally running over top of the earth. So if we look at a diagram like this, it's not very descriptive. I don't know who drew this. It wasn't me, but they probably could have done a better job. But this is probably a type of diagram that they love to put on that MAAP test. Just letting you know, you may have seen stuff like this on your benchmarks. So if you see, like up here, we've got rain coming down from the sky, and it's pointing at a lot of streams that is just kind of running over the surface of the earth. So this would be our runoff. Sick. So runoff typically will lead toward what we call surface water. So surface water is water on top of the earth that is there permanently. So it doesn't really move. Where with runoff, it shows up when there's a lot of rain and then it normally runs into surface water or goes down these like storm drains. But actual surface water is there on the surface of the earth permanently. These are your lakes, your ponds, your rivers. They're always there. They don't just dry up and then show up again, right? So they are there permanently. And that's where runoff often will lead into surface water. So here we have that runoff. It's leading into this big body of water, which is surface water. Oceans are surface water too. I don't know if I said that. But a lot of times runoff or extra water can lead into the ocean as well. So yeah, runoff, surface water. The next 2 terms that are related to these, I think they're a little bit trickier because these are ones that we can actually see firsthand with our eyes. The first one is infiltration. So when we say something is infiltrating something, it just means it's like entering, or you can think of like breaking in. So infiltration is when the water on any type of surface on the soil is going to actually seep into it and enter it. Just like I talked about up here to actually feed those plants, right? So if we look at this diagram here, we have the arrow pointing from the water, pointing down into the ground. So we know that this right here must be the infiltration. So the next question is, okay, we're sending all that water into the ground. Where does it go? Where does it go? So last bit is called the groundwater. So believe it or not, if you look at this picture right here, I think this shows it pretty well. Deep into the ground, there's actually a significant amount of water deep inside, like the crevices of that bedrock. Or there are some spots where it can actually go all the way beneath it, and it kind of holds it like a big, almost like, think of like an underwater lake. That's where you get your groundwater. It's getting me choked up just thinking about it. So your groundwater is also where you're actually going to get a lot of like your well water or any natural water that we use. It usually gets pumped out of the ground. So any large amount of water kept beneath the soil is that groundwater, which again, easy to remember that it's groundwater because it has the word ground in it. Literally means that it's in the ground. Okay, that's all we got for the day as far as your notes. So here's your cheat sheet. Not a whole lot to put on there. Just again, the layers of the soil. Don't you dare forget that it's broken down by weathering. And I reminded you of the difference between mechanical and chemical weathering. And of course, those keywords like organic means living. So if you see inorganic, that means the opposite. It means it's not living. And then here is your water cycle. Again, just for a refresher. Don't forget to do your independent practice, people. It's going to be a link to an ed puzzle on today's assignment. We're just going to go through a couple of practice problems just so you know what to expect when you hit up that MAAP test. So it's not going to be anything long, anything too crazy, just a little bit of practice. So yeah, I'll see you there.